Hello and welcome to Algebra 2 tutorial. In this video we're finally going to take a look at solving equations with exponents and square roots, or any kind of root actually. We've been getting good with exponents and roots, and so now we finally know enough about how to manipulate them to put them into equations and solve for x. So we're going to start off easy and then work our way up to some harder ones. So here are two easy equations that have roots in them. As you can see, we're going to do cube roots and square roots. You could do any kind of root. The process is basically the same. So the first main strategy is to get rid of the things on the outside of the square roots first. Alright, so we have a 5 outside the root and an 8 outside the root. We're going to deal with those first, and we get rid of addition and subtraction first. So we're going to minus 8 to both sides. So the 8's go away. 23 minus 8 is 15. Then we'll rewrite what's left over. We've got the 5. We've got the cube root of x minus 3. Alright, so we still have a 5 on the outside, so we're going to get rid of that next. So divide everything by 5. So the 5's go away. 15 divided by 5 is 3. And we've still got that equal to the square root of x minus 3. So now we're finally getting ready to get rid of that root. Cube root, sorry about that. So how do we get rid of a cube root? Well, the opposite, or the inverse of a cube root, is raising it to the power of 3. So we have to raise that one also to the power of 3. 3 cubed is 27. And x minus 3 is now all by itself because the cube root and the cube cancel each other out. And then we just add 3 to the other side, and x is equal to 30. Alright, one more easy one over here. This one's even easier. It looks harder at first though. We've got square roots on the left, square roots on the right. We've got to get rid of them. Thankfully, to get rid of a square root, you square it. That will cancel those out, but you got to do it to the other side, and it will also cancel that side out. So that's really, really easy for us right there. They both cancel. So you've got x minus 5 on the one side and 2x plus 7 left over on the other side. Now this should be just autopilot from here, nothing new. So let's just get everything to one side. Minus 7 minus 7. That goes away. Negative 5 and negative 7 make negative 12. 2x minus x is x. 7 and negative 7 go away. Hey, look, and we're left with x is equal to negative 12. So, hopefully I didn't lose you too much there. The main new thing is that the square roots then cancel on both sides. All right, those are the easy ones. Let's move it up a notch or two. So we've got easy square roots taken care of. Let's go to fractional exponents and see how those work. So here we've got two examples. Again, we're going to start out almost the same way as always. Get rid of the stuff on the outside. So we're going to add 20 and then divide by the 6. So I'm hoping that part isn't too new here. We get 24 is equal to 6x to the 4/3. Divide by the 6. And now we're finally going to do something new. 24 divided by 6 is 4. So now it's time for something new. How do we get rid of that 4/3 exponent? Well, we're going to raise it to the reciprocal power, 3/4. Now what does that do? Well, remember, we have an exponent property, which means these two are supposed to multiply by each other. So this will be x to the power of, on the top, 4 times 3 is 12. And on the bottom, 3 times 4 is also 12. Well, 12 over 12 is just 1. So this just becomes x to the first power, which is just x. So you can see the 3/4 power canceled things out and left us with just x. And now this is mostly a job for the calculator. I think I made this one work out really nice, but it is just a calculator task. So let's pull up the calculator here and do 4, let's turn this on, 4 raised to the power, now make sure you use parentheses, 3 divided by 4. So we're doing 4 to the, and you didn't make it work out nicely. It is 2.828, oh well. Good thing we have a calculator there, 2.828. All right, another fractional exponent one. This one, I said fractional exponent, but it does have a cube root in it. And so the first thing we're going to do here is rewrite that as an exponent. So the parentheses are really important, that all of this is raised to the 5th power. So I can write the 2x minus 1. It's raised to the 5th power, but the cubed root gives that a denominator of 3. So that's 2x minus 1 to the 5/3. That is equal to 10 still. I didn't do anything to both sides because I didn't actually change this. I just rewrote it as something equivalent. Now, how do I get rid of the 5/3? Well, the same way we did it over here. We used a reciprocal power. So I'm going to take this to the power of 3/5, which means I'm going to take this to the power of 3/5. These exponents will cancel out, and you're left with 2x minus 1. And on the other side, I got to figure out what is 10 to the power of 3/5. Again, that's calculator work. So 10 to the power, use parentheses, of 3 divided by 5. So it's 3.98. 3.98. And now we just add 1 and divide by 2 to finish this off. So 3.98 plus 1 is 4.98. 4.98 divided by 2 is 2.49. So the main new strategy we have here is using a reciprocal power to get rid of an exponent. All right, we got one more to look at. Sadly, it's the hard one. How do we take care of harder square root problems? So here we've got almost as hard as it gets. So we've got a square root on one side but no square root on the other, and that actually makes this harder. But we do need to get rid of that square root, so that is our first area of business. We're going to square that square root. That will get rid of the square root. But whatever we do to one side, we've got to do it to the other. So over here, we also have to square that. So on the right, this is nice and easy, 3x plus 30. The left, however, x plus 4 squared, we have to multiply out. So you're going to have to do x plus 4 times x plus 4, and you're going to have to distribute that out. I can do that in my head pretty easily. That is x squared, 4x, and x times 4 is a total of 8x's, and then 4 times 4 is 16. If you can't quite do it that fast, multiply it out, combine like terms, and finish that up. Alright, so I've got this equation now. I'm hoping this looks familiar. We have done this much before, but if you want to remember how to do it, you need 0 on one side. So we're going to subtract 30. I'm going to line up my like terms, and I'm going to subtract 3x as well. So the x squared, nothing happened to it, so it stays. 8x minus 3x is 5x. And 16 minus 30 is negative 14. Alright, so now we have a quadratic that equals 0. We'd have to solve this. And we've got some options. We can try to factor it. We could complete the square. We could use quadratic formula, a, b, and c. I think I made this one easy, so I believe this does factor. So we've got 14. What multiplies to be 14 and adds to be 5? 7 and 2, and the 7 has to be negative, it looks like. So x minus 7 and x plus 2 equals 0. So our answers are 7 and negative 2. There we have it. So those are our two solutions to this equation. So the big thing here is we only have a square root on one side, so when we square both sides, we have to do a big multiplication here, which gives us a quadratic, which we have to use some old skills to solve, either factoring or completing the square or the quadratic formula to get our solutions. Alright, so that pretty much completes most of all the ways you can solve an equation using square roots, roots, or fractional exponents. So let me give you a few to practice here. Try those out, see if you can get x by itself. Good luck!